Okay. Well, hello. You've all agreed to the contribution agreement, so thank you for that. First of all, let's introduce ourselves. So I'm Benji. I'm the person who created Grafast, and I maintain a suite of open source tools. Yeah, that's me.
Great. I can continue. I'm Mike Ditwolk. I live in the Netherlands, east of Netherlands, actually. Um, my expertise is front-end developer, you could call that, but I'm pretty much interested in like the whole spectrum, like the whole stack. So and I just recently at my new I'm an independent contractor, so I joined a new company or took on a new assignment, and that's where they just started migrating from post GraphQL 4 to 5, and now I'm just interested in like some deep dives and also what's underneath the the hood with Grafast and see where that's going.
Lovely. Uh, we have a few other people who are going to be silent on the call. Some more may connect a little later. But yeah, there's nothing. So I guess the easiest thing is if I just jump straight in with a status update, since no one seems to want to bring any additional tasks. So give me a second and I will get the slide sharing working. Right. Hopefully you can see a big orange screen, status report Grafast. Okay. I turn on the laser pointer. That's often handy. Okay, great. So we launched Grafast or the very first version of Grafast at the GraphQL conference last year, and organized a working group shortly thereafter, where we talked about some of the bigger issues that had yet to be fixed. We have since then done some more work on Grafast, and two of the very major, excuse me, I need to let someone into the call. There we go. So yeah, two of the major features since then have been addressed. One is global dependencies and one is early exit. We'll cover more on those shortly. We still have a couple of others that still need to be figured out. Partial planning for polymorphism and exportable plans for plan caching, though we don't necessarily need that in a version 1, but it would be nice. And there's a new topic that I'd like to introduce as well, which is eradicating eval. So let's move forward. Let's have a look at a couple of the things that we've implemented. First of all, global dependencies. In the initial version of Grafast, everything was pretty straightforward and worked in the exact same way, but that led to posts like this having a particular issue. Because everything was batched, when we ran the authors field inside of the top posts field, there would be as many instances of this number 5 as there was posts. So if there was, for example, 6 posts, we would have 6 copies of the number 5, which is kind of awkward. Now, it made it simple because every batch always worked with the associated values in each entry. But it meant that if you wanted to, for example, do a select statement to select all of these values, but knowing that you want that second value to be the limit, you had to either go through and check that every single one of these was the same value, or you needed to do some grouping by that and then evaluate each of the different groups, of which there would normally only be one, or various other ways of solving the problem. So what we've done instead is we've effectively reworked how the values are passed. So previously, they were passed in as simply a tuple that contained the direct lists of values. Instead of that, we now pass in a tuple which contains this object, and inside of this object is the values. But there's two forms of this object. There's a batch object and there's a non-batch object, which we're calling a unary object. So now we can say this thing only has exactly one value, and it's the same for everything across all the other values in the batch. So now we can put this batch of values in here, and we know there's exactly one value to put in this placeholder here. And when we add a dependency to our step, we've introduced, in addition to add dependency, which we had before, we've added add unary dependency, which gives you the ability to say, this thing must be unary. And that would be what you'd use in positions like this. So that is now solved. It has been released. It works in PostGraphQL, so a really large use case for Grafast. And it's working really well. And I think it actually has improved performance in some situations as well. Probably worse in others as well due to the slight overhead of creating extra objects. But in general, it does seem to be better. So great solution to that problem. We also had another issue, which we called early exit. So with all the value batching that we had before, it was perfectly valid, to have nulls as the input to various of these positions. So if you receive a null, that doesn't mean that you shouldn't execute the step. For example, you might have a user with a null bio. That's fine. You can still represent them as an object, for example. But sometimes you have a null that means that you shouldn't take an action. So for example, if you were to get a user by their ID and you were to feed in null into it, there'd be no point in actually going and fetching from the database where ID equals null, for example, because there won't be any records like that. So we know that this shouldn't be needed. And there's also other situations where we can infer this, like errors or empty lists and things like that. So we've introduced this new a new system internally to Grafast, and this new step function called inhibit on null. So what this will do is, if B is null, then anything that depends on the result of this on $A will automatically be null and won't be evaluated. You can also use things like assert not null, which will do the same kind of thing, but it does it by raising an exception. And then on top of that, we've introduced the ability to trap the fact that you've got an inhibit. So if you inhibit something, everything that depends on it should be null, except for a trap step, which can trap it and say, if it was inhibited, I want you to instead turn it into, for example, an empty list. And this can be useful if, for example, you want to say, show me, I was going to say all of the friends of this user, but that doesn't really make sense. But show me a list of things based on an input, and if that input's null, then we know there won't be anything in that list. But returning an empty list is perfectly valid. We can also theoretically use this to trap errors, though that functionality seems to have a bug at the moment. It was never actually tested, so that's a thing that we need to improve. But theoretically, it's possible. And we do this internally by using bit masks to flag the values in the system so we know whether they're an error or a null or whether they're inhibited or not. And all that trap does is it adjusts the flags that it accepts on input. So by default, things accept nulls, but they don't accept inhibit and they don't accept error. But trap can be configured to accept additional values. So here is a somewhat complicated example of this. Excuse my cat, she's very noisy today. So here we might have a root level field called posts by author ID. And this takes an author ID as an argument. Now, it's reasonable here to have a null, to say, show me all the posts with no author, where the author ID is null. And that's absolutely valid. You might have anonymous posts in your system, so you'd want to return a list of those. That's fine. Now, keep in mind that ID here might well be a GraphQL globally unique object identifier. So I'm not encoding it with base 64 or anything, just showing it with the type and the ID here. If you ask for all of the posts by user 27, then it would be reasonable to go and get all of those posts. But if you were to ask for all the posts by room 101, well, rooms can't be author of posts, so there's no need to even go and look in our data source to see what is there. Really, we just want to return an empty list, like the room doesn't have any posts. And it might be we want to return an empty list or a null to say this makes no sense, or even an error. It's up to us to choose that. And so this is the flow, how this works. We decode the ID, and that will give us a spec object. We told it to use the user's handler. So if it can't decode it as a user, the spec, because this is still planning, this is a plan step. Spec.id is a plan step. So we don't know what it is yet. We don't know whether it's valid or not. So the value of this will be represented as a null or not at runtime. So we then want to say, if that user ID was null, then we want to inhibit, don't do any further fetching. But we only want to do that on the condition that the original ID that came in was itself not null. So if this is null, carry on, don't inhibit. If this would be valid, so the ID here would resolve to the 27, and that's fine. And finally, in this example, the 101 wouldn't decode because we told it as a user type. So it would give this ID would represent a null at that point. We would inhibit this null because the original ID that came in, this value here, is not null. Bit of a complicated example, but that shows how this mechanism works. Finally, we get the post by author ID if we're not inhibited. And if we were inhibited, we just trap that and return an empty list. So we do now have the way in planning to handle these more complex situations. Now, of course, a lot of this could have been handled by just the way that you write your step in the first case, handling all of this logic as part of the step. But there is cases where you actually do want to plan. For example, node IDs is a really big example where this comes up. And in fact, it's the only example I've come up with so far that is in common usage. So it is a bit of a narrow use case. Nonetheless, it is now addressed. Grafast itself, as you may know, I've been working on since 2020. It's had 5 major rewrites already, and it has built up a large number of ways of handling errors and was becoming quite messy, to be honest, for the error handling. So we have replaced that with this new system that handles the early exit problems that we were talking about before. So rather than the new Grafast error and promise to reject and all the other things, we now give you the ability to just to throw anything. So you can throw a number now or any other value if you want to. It wouldn't necessarily make sense. But when we trap an error, we will then flag it to say that that's an error with a bit in the bit mask. And that means that any value can be an error. But also, importantly, it means that an error can just become a value. So, for example, if you want to plan something and extract the message from an error, you can now do that through the planning system as well, which wasn't possible previously because errors weren't recoverable. I've introduced a new branch step that gives you the ability, if you're handling polymorphism, to do things quite easily. So you can say that an animal is going to be one of these types, a cat, dog, or hamster. You can give it a match function that decides whether it matches or not. So in this case, we just look at the type property and see if it's feline or canine. And if you want, you can also give it a plan that will take in the original object and return what should be used instead. So for most things, we just use the object directly. We see that it's a feline, but we still use that same object. But in the case of hamster, for some reason, the values of that are nested inside of the data property on it. So we have a way to resolve that. So this is just notification of that new step. We also have a new side effect step. This is essentially the same as lambda, but with a lambda with a has side effect equals true afterwards. But we've created its own step to make it clearer how to write that kind of code and to make it easier for people reading that code. Another thing we've done is made load one and load many faster, and we've done that by just changing the way that we were waiting for the callback. So previously we did it with a 0 millisecond timeout. Now we do it with process.nextTick, which runs sooner. And that's actually turns out to massively improve the throughput of load one and load many if you are running at high scale. It doesn't really matter if you're running at low scale, it doesn't make much difference there. We've also added a helper to get the node identifier, the GraphQL global object identifier, from a node record. So this is just to help you, save you from having to write 5 lines of code. You can now use this little helper. There has been one breaking change. Well, there's been a few, but this is one of them. If you were previously hooking the args on the plugin Grafast, which is very unlikely that you were doing, but if you were, this is now implemented through a middleware system. And the middleware system is actually really important. Previously, the hooks were something that would happen at a position in the code, and that would be it. But the middleware system instead wraps a code, for example, like a function or something like that, which means that you now get the ability to do things beforehand and to do things afterwards, and they nest so that you can do things like start a timer, do the rest of the function and the rest of the hooks, and then stop your timer and see how long certain things took. Or you can use them for telemetry or all sorts of things. So this is a relatively minor change that results in quite significantly improved possibilities or powerfulness of the software. We've also introduced some more defaults. So originally, access was used a lot, but we used .get to track that a field has been requested. And as this became more and more of a convention in the system, as we built more and more stuff, we realized that actually we want to encase this as a common pattern. So now if you don't create a plan resolver for a field, it will see if your step has a get method. And if it does, it will call that. If it doesn't, it will use the old system of access the field name property on the step. But yeah, one of the great things about this is it means you can implement your own get function that accepts fields that may not be just simple data. So for example, the edge step uses the get of cursor to actually plan the cursor and return the cursor plan, as you can see like this. So we used to have to create a cursor plan resolver that takes the edge and returned edge.cursor, but now we just have edge.getCursor as the default, and this code is no longer needed at all, so we can just get rid of it, which is really nice. There has been a few major changes, one of which is the entire signature to the execute method in your step classes has changed. It's changed only a small amount. And in fact, if you want to make it so that you don't have to change the rest of your function code, all you need to do is just change the signature of execute itself and add this one line of code here that will then convert it back to how it used to be. And this is all to deal with the new unary values. So effectively what this code does is turn them all back into non-unary values, even if they were unary values. We also now accept this as an object rather than as additional arguments, just makes it easier to iterate over time. And we have, if you hit an error because of this, you should get this link, which gives you further instructions on what to do. Grafast itself used to accept the GraphQL options object as the first argument, and then additional Grafast specific options as additional arguments. We've deprecated that, still supported, but it's now deprecated. And instead, all of the options should be specified in that first object. So we now take the GraphQL object and we allow you to set additional properties in addition. There is, right, so then remaining issues. Partial planning. One of the issues we have at the moment is that planning of polymorphism can be really, really expensive, because we effectively enumerate every possible type that polymorphism could be, and then we plan each of those trees. If you then have a child of that can be polymorphic as well, we'll do the same thing, and this can multiply up, and ultimately it can result in your planning being a very significant undertaking. So we recommend at the moment that you only use Grafast if you're using something like persisted operations or trusted documents, so that you know that you are the people that have written this and you don't need to worry too much. We also have a planning timeout that you can use to help protect your server. But ultimately, we want to solve this problem. And the plan is to plan up until you get to the boundary of the polymorphism, and then to stop and plan the rest of the document. Then at runtime, we'll find out which parts of the polymorphism are needed. For example, we might discover that a cat object and a dog object were received, but like fish and gerbil were never seen. So we would then continue planning from that point, even though we're doing this at runtime. Planning is synchronous. So we would then just do the rest of the plan from that point for cat and dog, and we would store that back to the plan. We could then execute that as effectively a sub-plan and send the result to the user. Cat and dog are then planned already for any future requests. But if someone suddenly requests fish, we would then do the same thing. We would just do a sudden partial plan for just the fish type, figure that out, execute it, and so on. This is our plan. I've crossed this out because it's from the slides from the previous working group, but that's not the plan anymore. Related but separate is exportable plans. So at the moment, as I said, planning can be expensive, but because it only needs to happen once, or it only needs to happen once in most cases, we want to be able to store the result of that and then just load it in future. And being able to store that to something like Redis or a file cache or to your database or whatever would be really nice. So the plan for this is that we might add an additional lifecycle method, something like export plan or whatever, that would output a JSON object that would be serializable. We'd then be able to serialize it somewhere, and then in future, when you need that again, we just pull in that JSON, we'd deserialize everything, and then we would feed that JSON into each of your steps to get the execute method to be used. Since execute and stream are the only two methods that are used at runtime, really, this should be quite viable. I think that we don't need to do this before 1.0. We can do it after 1.0, and effectively you would only be able to cache the plans where every step class in your plan supports this new lifecycle method. But I don't think that would be problematic. So yeah. Oh, there we go. So we do plan, optimize, tree shake, and then we'd introduce this new step where we export it as JSON, and then in a later instance we can import from JSON and do finalize to build the final execute. This final one, eradicating eval, is a much bigger problem, and it all comes back to what we saw right at the beginning of the talk with the unary values. One of the solutions that we had to the problem of getting the fives, so many fives, was instead to actually evaluate what that value is at planning time. And by doing that, we would know that this is the number 5. It would never even be passed through as a step because we know what its value is, and you would just write it somewhere. And effectively, then it would be hard-coded into the SQL that was generated. So this is how quite a few things in PostGraphQL work. In particular, first is a good example of this. But because we now have these unary batch steps, we don't need to do that anymore. And it turns out that eval, well, we knew all along, eval is a really problematic thing, because anytime you eval something, you split the plan. You effectively add a constraint that says, when I see a next thing that wants to use this plan, check to see that this particular value is the same. So if you eval the first argument, for example, and it was 5, it would then check to see that that 5 was used again. Is my video frozen? Zoom's gone a bit weird.
No, it's fine, your audio as well. At least
Okay,
for me.
good. Good. It's just a local version of of Zoom messing up. Good. So that branching of the plans is not ideal, and the more you do eval, the more that branching happens, and the more plans you end up with in memory. And this is something we want to avoid entirely. So I would like to get rid of it entirely. Now that we have unary, we shouldn't need it anymore. We should just be able to do things by forcing things to be unary and then dealing with the values of that unary at runtime. However, it's baked into a very significant portion of the way that PostGraphQL has been built on top of Grafast. It's built into the way that Grafast handles planning of arguments. So arguments and input values can have plans on them directly, rather than only just having the resolvers on object fields like in GraphQL. So all of that is tied quite deeply into eval. So this is going to be another one of these huge systematic rewrites that we need to do. And I think that what we might do is actually just do it a bit by deprecating eval, showing how to use alternatives, and then just slowly working our way out of removing it from the system. And hopefully this means that we actually can release Grafast v1 without needing to fully eradicate eval, which would be nice. Nonetheless, I would like to do at least some planning work on this before we release v1, just to make sure that it is actually viable. In particular, I have issues with how it's going to work for things like the PostGraphQL filter plugin that has a whole bunch of deeply nested filters with lists and all sorts of stuff, which at the moment is quite heavy on the planning side. There are a few other things that we need to cover. So formalizing of sub-procedures, are classes the right abstraction, noting that error handling has evolved, and the apply transforms workaround. So let's pop into some of those. Sub-procedures are when you might want to run steps within effectively a step itself. So, for example, you might want to have a step that represents a database transaction, and then you might want to perform a number of steps within that. At the moment, the intent is that you encapsulate all of that with a single step that does all of it, and you build your own step class to do it. And that's similar to how you would just build your own resolver in GraphQL. And you can do exactly the same thing in Grafast, of course, because Grafast supports resolvers. But if we want to do these things at planning time, things get a little bit more complex. So it would be nice to create the ability to have a sub-procedure that goes on, executes the underlying steps within a certain context, and then tears that all back down and returns the result of it back into the parent plan. We have a little bit of this already in the form of list transform, which we use for each and group by and a number of the other built-in step classes. And we also have a pair of that, which is the apply transforms, which forces these things to evaluate. So for example, if you use each, normally we don't actually perform the transform until you are iterating over the individual items, which would be done through GraphQL. But if you wanted to, for example, take that transform or that thing that represents the transform and then feed it into, let's say, your database as a transformed list, you would need to force that transform to happen earlier than usual. And that's why apply transforms exists. So we would like to make that less manual. Here's an example of doing some planning with a transaction. You might get a transaction, make a user with that transaction, make a profile with that transaction, and then finally return the result. And this way, if anything were to go wrong, we would want the with transaction step to roll back those changes. So this would be a really nice feature to have, but not one that we have yet. I'm still not 100% sure, and in fact, pretty sure that they're not. Step classes at the moment are classes, but I'm not sure that they should be. If we think back to what I was talking about before with this export as JSON and import as JSON, it would be nice if the step itself was just represented with a serializable JSON object, and then we had something that was responsible for executing it and helping to plan it that was to the side, that doesn't necessarily need to be a class. It can just be an object or whatever. We also have things like the proxy step that does some really weird stuff. I do not recommend that you play with that unless you really, really need to. Wrapping steps with other steps can break chaining and various other things. This is going to get more of an issue with the trap step, which effectively like inserts itself, but it also means that because it is a trap step that exists in planning, you can't, when you depend on it, you can't necessarily see through it. So you wouldn't see that that was coming from, for example, a Postgres expression, which would prevent certain forms of inlining. So yeah, it would be nice to split this into like a state object and give that some kind of behavior that can control that with the lifecycle methods. I talked about the apply transforms workaround already. But one of the things there that I would like to do is automatically detect when you're directly consuming it and then transform that, but I don't know how to do that yet. So this is something that very much needs exploring, so that if you do an each, here's actually a work through example. So normally we would like take a thing like users and we would map it with an each to get the name. And it's only when you would then paginate that in GraphQL that the name value would be evaluated. Otherwise, you actually get the full user object still. So if you were to feed names at the moment directly into a Lambda, you would actually receive the full object, which obviously isn't what we actually want here. So at the moment, the workaround is to add apply transforms, which forces it to happen early, and then your names actually represents the Alice and Bob. But it would be nice if the fact of putting this into Lambda means that the system knows it needs to evaluate this prematurely. And one of the reasons that this doesn't just happen automatically is because it's much more efficient in the vast majority of cases to not do this transform upfront. We'll be mapping over the items in this array later anyway. So rather than looping twice, we may as well just loop once, and that multiplies up as the queries get more complex. But nonetheless, it does make this example very confusing. and the fact that you have to use apply transforms a bit special. Yeah, okay. So that is 40 minutes of a status update. Those are the main topics that I wanted to bring to say things that we need to work on. They are also the final items on the agenda: partial planning, exportable plans, and eradicating eval. So does anyone have any questions, feedback, ideas?
The only thing without like in knowing about it in depth, but I'm just gonna ask the question anyway. That transforming the plan or the partial plan to JSON and then uh, reading it out again, is that gonna get expensive, or is this a one-time thing?
The idea of this would be if you wanted to, you could. So this wouldn't be forced. Normally, you would just go from tree shake straight down to finalize.
All right.
But if you want to, then you could export it. And that would mean, for example, if you're running like 20 servers and your GraphQL queries are quite expensive, then being able to plan them on one server and write the result out to Redis, and then when another server sees that query, just being able to pull in the plan for that would be much more efficient. A lot of the cost of planning is in polymorphism, but it's also in deduplication. So avoiding that can be desired. So it would be a nice feature to have.
All right. Yeah. Thanks.
Okay. Thank you for your comment in the chat, Theo. No comment, but excited to see progress. That's great. Yeah, these are these are complex problems, and it's taken me a long time to solve those two previous ones, and these future ones, in particular, eradicating eval and partial planning, promise to also be quite challenging. But we'll get there, and I'm excited for the future. Once we've got this, I think this will be like an absolutely excellent planning system for any GraphQL API, no matter what data sources it uses. So I'm still motivated. The main issue is just finding the time.
Yeah. As like Steam, because these are such complicated topics. Do you have like any starters? Because I would love to help out, but on this level to start out, it's a bit. I think it's a bit too high of a hill to climb.
Oh, absolutely. Well, to be honest, anything that helps me get through the rest of the work that I need to get done so that I can get on to dealing with these problems is helpful as well, right? So you don't need to directly solve these issues. Also, testing and finding issues is also really useful.
Right.
On GitHub, I have I'm just looking for the label now, which is I thought it was help wanted. Yeah, help wanted. Which apparently I've only got 2 issues that are labeled as help wanted. Actually, let me stop sharing for a second. This. How do I full screen? There we go. Okay, let's try sharing this. Okay, this is the what I call the V5 board. This is everything I want to get done before V5 of PostGraphQL goes out, but it's also tightly tied to Grafast. Grafast originally existed to power PostGraphQL, but also to be a generic execution environment. So I've put various things into various categories, but in particular, there's 2 columns that people are more than welcome to help with. in many cases, this is a case of like reading the docs and reading the source code, and then adding the missing pieces. So there's a whole load of issues here that relate to things that are missing from the documentation. So things that I've, for example, added the capabilities of doing and maybe roughly documented in terms of what I've written in the pull requests or what I've built in terms of the tests that check that the functionality works. But I haven't then extrapolated that up and made it user facing by putting it into the documentation itself. For example, like this top one, tell people who aren't using TypeScript that they may want a specific jsconfig.json. That's a really quite straightforward issue, but it involves actually like creating that JSconfig file and then testing it in VS Code and making sure it works. And it just needs someone to spend the time. And at the moment, I'm not prioritizing these because there's more complex stuff. So any of this that you feel that you could address would be really helpful. Test improvements are obviously just creating more tests for various things. A lot of these actually come from the old repository before we merged, but that doesn't really make any difference. Let me see if I can. So when it comes to making tests, certainly if they're PostGraphQL tests, they're very straightforward. Essentially, you create a GraphQL file like this one in a folder like this, and it's just a GraphQL query, right? Or query in fragments if you need them. And then up top, you can put assertions like expect there to be no errors. And you can add configuration, which use these triangulars. So this says use the database schemas A, B, and C, turn on subscriptions, use this configuration option. Different ones of our tests use different configurations here. But broadly, to write a test, you need to create a file like this and put a GraphQL query in it. Then you run the tests. When you run the tests, it will create these additional files for you. So it will create the SQL, which shows exactly what ran in the database. It will create the mermaid diagram that shows you what happened, like in terms of planning. And it creates the JSON5 file, which shows you what the output is. You would then have a look at this, make sure that it is reasonable. Does it look right? Yeah, looks fine. And that's it. Test written. So writing tests should theoretically be really straightforward. It's just something that needs to be done. And there's a lot of like edge cases that aren't. So that's another great way to contribute.
All right. Thanks. I'll go through the board and see what I can pick up.
Perfect. To find that board, by the way, just go to the root GraphR and then projects and then the V5 inside of that.
Great. I'll do it right now.
Amazing.
Thanks.
Okay. Thank you so much, everyone. I think since there is no further questions or no further questions, I'll go ahead and go on to
Benji, just a small one. I think on our end, we'll try to integrate a bit Grafast in our own GraphQL server to see a bit how it goes. No news now, but we'll definitely have a look in the next weeks and we'll give you feedback whenever we find something that works or doesn't work.
Amazing. That sounds great. Do remember at this point to use persisted operations or trusted documents with it. Awesome. All right. Thanks, everyone. And we'll catch you next time or on Discord.
Thank you. Good work. Have a good day. Cheers.
Great work.
Thanks.
Cheers.
Thanks, everyone. Bye.